Welcome to the lesson. This is for Tuesday, December 1st. We're taking a look at factoring higher order polynomials. So we're talking about x to the third and x to the fourth lately. Now we're going to learn how to factor some of these higher order polynomials. So a quick review. How do we solve by factoring? We've learned this before. We start by setting it equal to 0. So if the equation's not equal to 0, we get it equal to 0. Then we factor, and then we use the zero product property, which means we set each factor equal to 0 separately. It's the mini equations. There's different factoring methods. You might look for a GCF first. That'll come into play later this week. There are special formulas that we learned. The conjugate rule, a squared minus b squared, is a plus b, a minus b. We're going to learn some more special formulas this week. We also have regular factoring, and that's just breaking it up into terms. We'll see that today. And then a new one called factor by grouping we'll learn, I think, next week is when we finally get to that. There are several solving methods for the zero product property, step 3. Regular algebra 1 solving is all we've been using so far. But we can also use solving by square roots and solving by quadratic formula or completing the square, which will come into play, I think, on Thursday. One of the next couple days. So how do we do this? So I take something like x to the fourth plus 8x squared equals 33. Now if I were to show you this equation, and we'll set it equal to 0 now too, earlier this year or in Algebra 1, you would say this factors by taking x squared breaks up into x times x makes x squared. Factors of 33 are 11 and 3 that multiply to make 33. And if I check my outer and my inner, plus and minus here, the outside would give me negative 3x, the inside would give me 11x, and those two add up to 8. 11 minus 3 is 8. So we're going to do the same thing here, only we have x to the fourth. So how does x to the fourth break up? Well, of course, x squared times x squared would make x to the fourth. And I'm still going to factor 33, 11, minus 3. Notice we already set it equal to 0, so we subtracted this 33 over. But 33 breaks up into 11 times 3, and that would add up to 8 in the middle. So it's still the same thing. I have these two factors, but I'm being asked to solve by factoring. So I'm going to do the zero product property, which some of you have been forgetting on the last several tests that we've done this. You factor, and then you never solve. You have to set each factor equal to 0 and solve. Some of you forgot it the first time. I told you about it. I made a big deal out of it. And some of you still didn't do it the second time. Make sure that you set each factor equal to 0 and solve. So here, my factors are x squared plus 11 equal to 0 and x squared minus 3 equal to 0. And I'm going to solve these by square roots. So how do I solve? First, I minus 11, and then I take the square root of both sides. The square root of negative 11 is plus or minus, don't forget your plus or minus, I square roots of 11. We popped our I out because we took the square root of the negative. So plus or minus I square root of 11. There's two answers, I square root of 11 and negative I square root of 11, both positive and negative. On this side, how do I solve? I would add 3 over, and then take the square root of both sides. The square root of 3 is plus or minus the square root of 3. I don't want the decimal. Just leave it as square root of 3 unless it breaks down. Now, if I get this plus or minus square root of 50, I need to break that down into 5 square roots of 2, like we talked about last week. Okay, for those who actually showed up on Wednesday. So I have plus or minus the square root of 3. So here's my 4 answers. I have plus or minus I squared root of 11, that's 2. Plus or minus square root of 3, that's another 2. And I got 4 answers, which makes sense because this was an x to the fourth problem. So I should be getting 4 answers. So we factor, set each factor equal to 0, and solve by square roots. And that's what most of today's is going to be. I can factor down here also on this one. It's a conjugate rule. This is a squared minus b squared. So how do I break up x to the fourth? X squared times x squared. 81 is 9 times 9. So I have a plus b, a minus b. X squared plus 9, x squared minus 9. Felt like I was reading Dr. Seuss for a moment. Red fish, blue fish, one fish, two fish. Okay. So what I have then is x squared plus 9 gets set equal to 0. You have to solve these. And x squared minus 9 gets set equal to 0. When I solve this side, I would minus 9, then take the square root. Square root of negative 9, pop your I out, but the square root of 9 is 3. So it's 3i plus or minus 3i. Over here, I would add 9 over and then take the square root. Square root of 9 is plus or minus 3. So I get plus 3i, minus 3i, plus 3, and minus 3. 4 answers. I can do the same thing with higher order polynomials. We aren't going to do much with this, but I do want to show you one. X to the 8th minus 625. This is another conjugate rule. X to the 8th would break up in x to the 4th times x to the 4th. Because remember your rules of exponents, when you're multiplying, you add exponents. 4 plus 4 makes 8. So I have 8 x's. I put 4 x's here, 4 x's here. 625, that's a perfect square. Told you had to know these. We're going to start memorizing them here. 625 is 25. So I break it up into 25 times 25 is 625. Now I can actually keep factoring because this is also a conjugate rule. So we're going to do the conjugate again. X to the 4th minus 25 can break up again. X squared and x squared. 25 is 5 and 5. 5 times 5. So I get x squared plus 5, x squared minus 5. And I'm just doing that a plus b, a minus b rule. Okay? A plus b, a minus b. Now I can't factor this with the conjugate again because the conjugate rule says it has to be minus a squared minus b squared. So I can't break this up anymore. So what I actually have is 3 factors. I've used the conjugate rule twice, and I now have 3 factors. I can solve this, minus 25, and then take the 4th root. And there are other answers here, but they're really hard to find, so I'm just going to say this is sufficient. Just say plus or minus I times the 4th root of 25. But these I can solve pretty easily. So I'm going to take x squared plus 5. I would minus 5, and then take the square root. Oh, square root of a negative, pop your I out, plus or minus I square root of 5. Over here, I would add 5, and then take the square root, plus or minus the square root of 5, and we'll just leave the answer that way. So there's 2 answers here, 2 here, there's actually 4 here, but they're harder to find, and we're not going to get into that yet. Okay? One more example, and it's still the same thing. I'm just trying to give more examples. And so I have x to the 6th. Oh, how would I break up x to the 6th? X to the 3rd and x to the 3rd. How do I break up 24? 3 times 8. Because 3 and 8 also subtract to make 5. So I'm going to solve x to the 3rd minus 3 equals 0. And x to the 3rd plus 8 equals 0. So I would add 3 over, and then take the cubed root of both sides. So the cubed root of 3 would be one answer. And I don't need plus or minus because I'm working with an odd exponent now. We'll talk more about that later. Odd exponents, it's plus or minus, it's not both. But I also can do x to the 3rd plus 8. So I would minus 8, and then take the cubed root of both sides. It says square roots, but we're doing cubed roots now. Cubed root of negative 8 is negative 2, and that's it. It's not plus or minus, because I can have negatives. With odd exponents, negatives are allowed. So I don't do the whole plus minus thing with odd exponents. Okay, we'll talk more about that later. Now, there aren't 6 answers here. There's only 2, and we're going to talk about how to get those. We'll learn that later, how to get the other 4 answers. So don't worry about that now. Just try to solve for those real roots. These are the only real answers. Negative 2 and the cubed root of 3 are the only 2 real answers. There's 4 imaginary that we'll learn how to find later, actually Thursday. Okay? All right, I tried to give a bunch of examples. The homework problems are just like these, so look at these examples to help you. All right? Go ahead and get started or go back to the live session if you want more help.